Okay, so we're back with solving equations with some other roots in here. So I'm taking this example from page 569. It's just a cube root equation. So all of our same steps as before. So we have to, before we can do anything, we have to get this alone. So I'm bringing over that 4. So I'm going to subtract the 4 from both sides. And I get a -1. This is where we ran into trouble with a square root equation. If I took the square root of something and got a negative, that's how we knew it was going to be an extraneous root. For a cube root, that's not going to be an issue because it's an odd root. But I will have to check for extraneous roots with when I have an even root equation. So now I have to, okay, so we're trying to get into that x and we're going to try to get rid of that cube root. Okay, so keep in mind that this is the same thing, just so you realize, as this equation. Let me put a little line here. Those are the exact same equations. I would solve them the same way. Both of them, I would cube both sides to undo that cube root. Okay, so watch how it works on both of them, no matter which way I have this. Okay, so on the left, if I have a cube root of something and I cube it, I end up getting just what's left in here. And now I have a nice linear equation. That's what sometimes gives me extraneous solutions, but for this one we won't have any extraneous. I'm going to add my 3 over, add my 3 over. So I have 2x equals 2, so we know x equals 1. If you check that, you'll see that that works. And over on the left, when the blue, well, the reason a cube root and a cube undo each other and end up canceling each other out is because look what happens here. When I raise a power to a power, I multiply exponents, which means this just equals 1. So I have just 2x minus 3 equals -1. So I have the same exact equation. If I solve it, I get the same result. So nothing different than you did last week, really. Just raising to a different power and knowing what power to raise to. Okay, so so now I took a 4th root. So we should keep in mind here that this right here, let's just kind of remember that this right there has to stay, whoops. Just for sake of practicing domain here, this, what's under the radical, has to stay positive. Okay, so if we happen to get an x value, so let me show you what happens if I'm actually going to add over the x. I'm just showing you the domain, really. I'm not solving it just yet. It would say that, okay, that actually says that x must be less than or equal to 2. I just kind of reworked that inequality. I added over the x and I rewrote it to the way we really like to have the x on the left-hand side. So what this means, I just have to keep this in the back of my head and say, okay, if I get any x that's not less than or equal to 2, this function's undefined for that. This equation's undefined. So we'll just kind of keep that in our head. So back to our problem. The 4th root is alone. I don't have to add or subtract anything, so I'm ready to raise both sides to the 4th power, because that's what will undo a 4th root. So I end up getting 2 minus x equals 5 to the 4th, so that is a 625. Okay, I will subtract 2. Now I'm just solving this. Remember, now this is a linear equation. So negative x equals 623, which means x must be negative 623. Whoops. Okay, so I'm just comparing. Remember back up here, we said x's have to be less than or equal to 2 to make this even defined. Make the left-hand side of that equation even defined. So my x is way below 2, which means this is not extraneous, which means I do have my solution here. X is negative 623 in order for that equation to be true. Okay, and I have one last example, exponent. Okay, so I'm going to come over on the side. So we've got 2x to the 3/4 minus 3 equals 51. I want you to just keep in mind that this right there is the same thing as this. It's the same thing as taking a 4th root and cubing it in either order. That cube could be inside, or it could be outside. it wouldn't matter which order I did them. Okay? I actually I'm not going to rewrite this equation in terms of radicals because the fractional exponent is actually easier to work with. But keep in mind, if I've got to do the fourth, if I'm taking the fourth root of x and cubing it, I've got to do the opposite things when I'm trying to solve. So first thing, my first goal is to get this piece by itself. So I'm going to add over the 3. And I'm going to divide out the 2 so I can focus on just that x to the 3/4. Okay. And so now I've got to, x is 2 to the 3/4 power, so the only thing I could do to undo that is raise it to the 4/3. Because now those 4's, when I multiply exponents, and those 3's totally drop out, and I get plain old x, which is what I wanted. And I have this. Now this I would like you to do without a calculator, because I want you to realize that this is the same thing as a cube root of 27, and you turn around and raise that to the 4th. Okay, so the cube root of 27, this part right here is a 3. To the 4th gives me 81. Okay? Some of these are very quick and easy to do by hand. There's no point even using the calculator. But there's my solution, x equals 81. You can check that, but that one definitely is not going to be an extraneous root. And hopefully those 3 examples help get you through this week's homework.